Hello friends, so in this video, we're going to do a very quick overview of Newton's second law of motion. So here we go. First, Newton's second law is kind of two parts. It's the just what does it mean part, what does it state, and the relationships piece. And then there's the math part, and we'll get to that in a minute. So Newton's second law of motion states that the acceleration of an object depends on the mass of the object and the force applied. So with Newton's second law, we're dealing with three variables here: acceleration, mass, and force. And the first part of this law is understanding what the relationship between those three variables actually is. So I'm going to give a very relatable example to all of us, a shopping cart, okay? So let's say you're at the store and you have a shopping cart that is full of groceries and a shopping cart that's completely empty. Well, if you apply the same force to each of those shopping carts, it means the force is constant, then you're going to have different acceleration rates for each of these. For the shopping cart that has more stuff in it, well, it has more mass, and so its acceleration is going to be lower. It means it's going to go slower. If you push on the empty shopping cart with the same force that you pushed on the full shopping cart, because it has less mass, that means it will go faster. So its acceleration will be higher. What we call this is an inverse proportional relationship. When mass is up, acceleration goes down, and vice versa. Well, let's say you had two shopping carts of equal mass. So the mass is constant in both of these shopping carts. If you want them to go faster, you have to apply more force. The more force you apply, the more acceleration you get. Likewise, if you push less with less force, the less force you apply, the slower it's going to go. So this is a proportional relationship. And then the last relationship between these three variables is the relationship between mass and force. If these shopping carts are moving the same speed or the same acceleration rate, then the shopping cart with more mass is going to require more force to get it to go the same acceleration rate as the cart that's empty that has less mass. It's going to require less force to get that cart to go the same speed. So those are the relationships, and lucky for us, it can be turned into a math problem. So Newton's second law has this formula: force equals mass times acceleration. And with some rearranging of the variables, we can also get two additional formulas out of this: mass equals force divided by acceleration, and acceleration equals force divided by mass. So I have one sample problem, and then we're done. Okay, so this sample problem actually combines what you've learned about calculating net forces on an object, so all of the forces on an object to get that one net force to determine if it's balanced or unbalanced, and taking Newton's second law into account with the relationships between force, mass, and acceleration. So here's our problem. Two students are working together to move a box. What is the acceleration of a 50-kilogram box if one student pushes with 10 newtons of force and the other student pulls with 15 newtons of force? So I know that I have to find the acceleration. That's what I'm looking for here, okay? I know my formula for acceleration is acceleration equals force divided by mass. But I don't have one force here listed. I have two forces, so that's telling me that I need to find net force. And so instead of just taking one of these, if they're going in the same direction, I know I add them. So my force here is 10 plus 15. My net force here then is 25. I had to double check my math there for a second. And my mass is 50. 25 divided by 50 is 1/2, right? Yeah. I should probably double check my math. You know, like sometimes you put 2 plus 2 into a calculator. That's where I'm at right now. Yes, 0.5. So my acceleration here is 0.5 meters per second squared. And it's that easy. It's that easy to combine everything we've learned about net force and Newton's second law. And that's it. So not that difficult, probably not as difficult as you thought it would be. And if you need any more help, just message me and I'm happy to help. See you later, guys.